So what are soft gelatin capsule and how we can differentiate from the hard gelatin capsule? Here in this image you can see that the hard gelatin capsules are having two parts, cap and body, whereas the soft gelatin capsule is having only a single body. So this is the main difference in between the hard gelatin capsule and soft gelatin capsules. So let us see one by one the introductory part of soft gelatin capsules. First, let us see the definition. So, soft gelatin capsule are one piece hermetically sealed soft gelatin shells. So, as we have seen, and from this picture, you can see that the soft gelatin capsules are having one piece as compared to the hard gelatin capsules, and these are containing liquid, suspension, or semi-solid preparations. Whereas in case of hard gelatin capsule, if you remember in the last session, in hard gelatin capsule we can encapsulate only powder or granular material, whereas in case of soft gelatin capsule you can encapsulate either a liquid, semi-solid or suspension type of medicament. Means as compared to hard gelatin capsule we can encapsulate the different varieties of the medicaments which are available either in liquid, semi-solid or suspension type of dosage forms. So soft gelatin is mainly composed of gelatin, plasticizer, preservative, coloring and opacifying agents, flavoring agents, and the sugars. What is the difference in between hard and soft gelatin capsule with respect to this composition? Main differentiation is just because of the plasticizer. If you vary the plasticizer content, hard gelatin capsule may get converted into soft gelatin. Generally, hard gelatin capsule contain less proportion of plasticizer, that is 0.4 is to 1 gelatin. Means this is the ratio of plasticizer to gelatin. In case of hard gelatin capsule, the ratio is 0.4 is to 1, whereas the soft gelatin capsule ratio is 0.8 is to 1. So this is the difference in between plasticizer content of both hard and soft gelatin capsule. So hard gelatin capsule generally contain less plasticizer, so that's why these are less flexible or having minimum softness as compared to the soft gelatin capsule. If you increasing the plasticizer content, the softness or the flexibility of your shell goes on increasing. So that's why soft gelatin capsules are softer as compared to hard gelatin capsule because they are containing more amount of plasticizer. And still, if you are going to increase the proportion of plasticizer after some time, the soft gelatin capsule may get converted into semi-solid type of appearance. Means it will get very soft in appearance, and that's why you may feel it like a semi-solid type appearance. So that's why we have to maintain the optimum concentration of plasticizer in hard gelatin capsule and soft gelatin capsules. What are the application of soft gelatin capsules? As an we can use this soft gelatin capsule as an oral dosage form. So this is mainly the soft gelatin capsule we are using for oral dosage form, but these are having some other applications also, that it can be used as suppository type of dosage form and as a specialty uh, packaged in tube form. Actually, the images are contrast here. Suppository type, you can consider this one image which is available in green and bluish in color, and the specialty package in tube form. So this is the image of specialty type of tube form. So this type of soft gelatin capsule generally we are using for ophthalmic purpose. In case of redness of eyes or any eye infection, we can use this type of tube form. So just you have to break the elongated portion of this soft gelatin capsule and insert into your eyes. So this is the specialty package or tube form of the soft gelatin capsule, and this one is the suppository type of soft gelatin capsule, and oval or oblong. This one are mainly used for oral type of application. Then advantages of soft gelatin capsules. Soft gelatin capsule used to protect the inner film of your inner film, that is your medicament, from oxidation and degradation. As we know that most of the drugs undergoes oxidation and degradation, mainly in presence of light or in presence of moisture. So as we are going to encapsulate this medicament inside the soft gelatin capsule, So indirectly we are going to protect this type of medicament from oxidation and degradation. Then we can also protect the medicament from UV radiation. As the medicaments are encapsulated within the soft gelatin capsule, so we can protect the medicament directly from UV exposure and we can protect it from oxidation. It enhances the illusions. Illusions means they are having very good looking, and that's why patients, mainly in case of pediatric, they can generally prefer to use this type of medications because they are having very good illusions. Suitable for medicaments like semi-solid, oily material or liquid form, especially non-water soluble. So as compared to hard gelatin capsule, we can encapsulate semi-solid, liquids or suspension type of dosage form. And this is the advantage of soft gelatin capsule over hard gelatin capsule. Soft gelatin capsules increase the viability of APIs, that is active pharmaceutical ingredient. So once you take this soft gelatin capsule with a glass of water, immediately the outer shell of soft gelatin capsule goes on dissolving and increasing and releasing the medicaments. So in this way, it gives faster absorption, and that's why there will be increase in viability. They are easy to manufacture, they are having very good illusions, and specialized dosage form can be made like chewable, extended release, etc. Here in this image, you can see different types of chewable and extended release type of soft gelatin capsules, and can also be used for ophthalmic preparations, that is called as applicaps. Here in this image, you can see the example of ophthalmic preparations, that is tube form of soft gelatin capsules. Then various disadvantages associated with this soft gelatin capsule. There are few filling equipments are available, and this is the major disadvantage of soft gelatin capsules. Manufacturing is expensive as compared to hard gelatin capsules. Drugs from oily vehicle may pass into the shell. So whatever the drugs we are encapsulating within the soft gelatin capsule, sometimes these drugs can penetrate through the gelatin shell. Soft gelatin capsule having difficulties in dealing with the water soluble material. So this is the main precautions we have to take with the soft gelatin capsules. Generally your gelatin is soluble in the water. So that's why we have to always take care of that. So, water and water miscible volatile component never allowed to encapsulating soft gelatin capsules. So that's why there is difficulty in dealing with the water soluble medicament. So water soluble medicaments are generally not suitable for soft gelatin capsule. Otherwise, it will dissolve the soft gelatin shell, and your medicaments may get rupture or it may comes out. Soft gelatin capsule are highly sensitive to moisture. So once you expose the soft gelatin capsule to high moisture, the soft gelatin capsule already they are very soft in the nature, and in presence of moisture again the softness will goes on increasing, and it may sticky to your fingers and it will be very difficult to take. And that's why we have to always protect the soft gelatin capsule from high moisture. Soft gelatin capsules having difficulty in dealing with efflorescent material. So in the previous session, we have already seen what is the effect of efflorescent material. So efflorescent material means that can release the moisture. So already your soft gelatin capsule are very soft in the nature, and again if efflorescent material start releasing the moisture, again it will get softened and it may get rupture. So that's why it is not suitable for efflorescent material. Again, in the same way, it is having difficulty in dealing with the deliquescent material. Deliquescent means that can absorb the moisture from your soft gelatin capsule. And once the moisture absorbed by deliquescent material, your soft gelatin capsule may become harder in the nature and it may get fragile or it may get break. So that's why soft gelatin capsule is not suitable for efflorescent and deliquescent materials. Next, let us start with the shape of capsules. The shape of soft gelatin capsule are round, oval, oblong or tube form. Here in this image you can see the different shapes of capsules. On the top side you can see different oval shape of the soft gelatin capsule. then round gelatin capsules, oblong gelatin capsules, tube form of the capsules, twisted off, and lastly the special shapes of soft gelatin capsules. And each of these capsules are having their own applications. Generally, oval, round, and oblongs. These are generally preferred for oral type of soft gelatin capsules. Tube form of the capsules are generally suitable for ophthalmic, and this type of uh, soft gelatin capsules are preferred for the suppository type. Twisted off and special package shapes type of soft gelatin capsule generally suitable for chewable type of dosage form. So these are different shapes of the soft gelatin capsules. Nature of capsule shell. It is composed of gelatin, plasticizer and water. Gelatin, plasticizer and water. These are the main components of soft gelatin capsules. So uh, we have to keep the optimum concentration of plasticizer. If the concentration of plasticizer goes on decreasing, then your soft gelatin capsule may get turned into hard gelatin capsule. So that's why there is major role of plasticizer. As we have seen before, the plasticizer contained in hard gelatin capsule is 0.4 is to 1, and in case of soft gelatin capsule it is 0.8 is to 1. So that's why we have to always take care of plasticizer concentration. Additionally, it may contain the preservative, coloring agent, opacifying agent, flavor sweetening agents to achieve the desired effect. So these other preservative we are adding to increase the elegance of your soft gelatin capsules. Gelatin is a USP grade with additional specification. So apart from the composition, it also uh, it has to uh, it has to achieve the following specification like bloom strength, viscosity, and iron content of the gelatin. So what is the bloom strength? In previous session, we have already discussed what is meant by bloom strength. So bloom strength is directly related to the viscosity of your gelatin. And in case of hard gelatin capsule, the bloom strength is about 150 to 150, and in case of soft gelatin capsule, the bloom strength is about 150 to 250. Viscosity. How to determine the viscosity of your gelatin? So first you have to prepare a gelatin mixture by dissolving 6.67 gram of gelatin in 100 ml of water and dissolve at 60 degrees Celsius. So once you dissolve the gelatin, you will get the 6.67 concentration of your gelatin solution, and the viscosity must be around 25 to 45 millipoise. Then you can prepare good quality soft gelatin capsules. Then iron content is also essential. Generally, in order to prepare gelatin solution, you require water, and water generally contains some concentration of iron. And whatever the type of water you are utilizing, finally you have to determine the iron content of your gelatin solution, and it should not be more than 15 ppm of iron. Then capsule content. Content may be a liquid, solution, or suspension of the solids in liquid. So, soft gelatin capsule may contain either liquid, solution, or suspension type of medicaments. So, it can be liquid like volatile in composition, or it may be a vegetable oil like arachis oil, or aromatic or aliphatic hydrocarbon, ethers, esters, or the alcohol. So liquid may be volatile in the nature, or it may be consisting of vegetable oil like arachis oil or aromatic oils. So solid that are not sufficiently soluble in liquids or in combination of the liquids are capsulated as suspension. So in short, those liquids which are not soluble in the water, directly you can prepare the suspension by using some suspending agents like lecithin and soybean oil. And liquid that are both water miscible and volatile cannot be included. We have already discussed this point. Those liquids that are water soluble or volatile cannot be included in soft gelatin capsule manufacturing. because if your liquids are volatile or water miscible in the nature, directly it will dissolve your soft gelatin shell, and after some time your soft gelatin capsule will get completely dissolved before administering to the patient. So that's why the liquids, those are water or water soluble or those are volatile in the nature, cannot be included. Volatile liquids we can consider, but it must be water immiscible. If it is not miscible in the water, then you can consider the volatile liquids. Similarly, plasticizers such as glycerin and propylene glycol cannot be major component of your capsule. Otherwise, it may causing the softening of your gelatin shell. So as the plasticizer concentration goes on increasing, it will goes on softening the shell of your soft gelatin capsule. And if you are going to increase the more and more amount of plasticizer, it will dissolve the gelatin shell. So that's why we have to keep the optimum concentration of plasticizer, such as glycerin and propylene glycol. Next one is the pH. pH of the encapsulated material. It must be around 2.5 to 7.5, because if the pH is more acidic, it may cause hydrolysis and leakage of the shell. And if the preparation is more alkaline in the nature, then it may causes tanning of your gelatin shell and affects the solubility of your shell. So that's why the pH of your encapsulation must be around 2.5 to 7.5. If it is more acidic, we can say near about 1 to 2, then it may causes hydrolysis and leakage of the shell. And if it is more alkaline, it may cause tanning of your gelatin shell, and it may affect the solubility of shell. The maximum capsule size and shape for convenient oral use is about 20 mm oblong, 16 mm oval, and 9 mm round. So these are the maximum capsule size and shape for oral use. Otherwise, the capsule size may be smaller or larger if we are going to consider for suppository type of dosage form or for ophthalmic type of dosage form. But if you are considering the soft gelatin capsule for oral purpose, then this is the maximum size given, that is 20 mm oblong, 16 mm oval, and 9 mm round. This is the maximum size of soft gelatin capsule for oral use. Then soft gelatin capsule composition. It consisting of gelatin 35 to 45%, plasticizer 15 to 25. Here in this image you can see the ratio of plasticizer is to gelatin. So for soft gelatin capsule, the ratio of plasticizer and gelatin is 0.8 is to 1, and in case of hard gelatin capsule, the ratio of plasticizer to gelatin is 0.4 is to 1. And in case of hard gelatin capsule, if the ratio we are going to decrease than this limit, suppose we are going to consider 0.2 instead of 0.4, in that case your gelatin may become very brittle or hard in the nature. And in case of soft gelatin capsule, suppose you are considering 1 or 1.2 instead of 0.8, then soft gelatin capsule may become more softer in the nature, and sometimes it may get rupture. So that's why plasticizer content must be as per the specification. For hard gelatin capsule, the ratio of plasticizer to gelatin must be 0.4 is to 1, and for soft gelatin capsule it must be 0.8 is to 1. Then water 40%, dyes or pigment as needed, opacifier as needed, and other flavorants, sugar as needed. So the main component of your soft gelatin capsules are gelatin, plasticizer, and water. And if in case you want to improve the elegance of your soft gelatin capsule, then you can add the following three ingredients, that is dyes, opacifier, or flavoring agents, or sugar. But above three ingredients are essential, that is gelatin, plasticizer, and water. Then formulation. The soft gelatin capsule may involves the liquid rather than powder technology. In this image you can see powders or granular material is only applicable to hard gelatin capsules. So whenever you are thinking about hard gelatin capsule, in that you can encapsulate only powdered or granular material. And whenever you thinking about soft gelatin capsule, you have to consider always liquid or semi-solid preparations. So only liquid or semi-solid we can fill inside the soft gelatin capsule. So this type of liquid material we cannot fill inside the hard gelatin capsule because it's consisting of two parts, that is cap and bodies, and again it is very hard in the nature, and because of liquid component it may become softer in the nature. So that's why powder or granular material is only applicable to hard gelatin capsule, and liquid or semi-solid material is only applicable to soft gelatin capsules. Material are generally formulated to produce to get the maximum stability, therapeutic effectiveness, and manufacture efficiency. So whatever the product we are preparing, that is soft gelatin capsule, so it is formulated to give the maximum stability. Stability means that is expiry period of your preparation. Suppose it is stated that the soft gelatin capsule will be stable up to maximum 3 years. So that is the maximum stability of your soft gelatin capsule. It will remain stable up to 2 to 3 years. Then therapeutic effectiveness. What is mean by therapeutic effectiveness? Suppose we are preparing the soft gelatin capsule of any NSAID drug, then it must give the therapeutic effectiveness until its stability. So up to maximum 2 year or 3 year, it may show its therapeutic effectiveness. It must be having ability to lower the raised body temperature. Then liquids are limited to those that do not have an adverse effect on the gelatin shell. Do not have the adverse effect on gelatin shell means what kind of liquids will affect the gelatin shell? That is water or water miscible volatile components. So this may having ability to dissolve your gelatin shell. So that's why this type of liquids are not suitable, or it may having adverse effect on the gelatin walls. Vehicle using soft gelatin capsules. What kind of vehicles are suitable? First requirement is it must be having compatibility with the capsule shell. Which liquid vehicles are having compatibility? Those are water immiscible in the nature and non-volatile. If it is volatile, then no problem, but it must be immiscible with the water. So water and water miscible volatile solvents are generally not compatible with the capsule shell. So what kind of vehicles are generally compatible? Those are having immiscibility with the water, that can be compatible with the capsule shell. Next, it must be having ability to dissolve the drug. Rate of dispersion in GI fluid after cell disintegration in GIT. Rate of dispersion means after what period your gelatin shell will get dissolves in the GI fluid. It will take maximum about 10 to 15 minutes to get dissolved. And ability to optimize the viability of the drug. So these are the four basic requirements of the vehicle. First, compatibility. Second, ability to dissolve the drug, rate of dispersion in GI fluid, and last, ability to optimize the viability of the drug. So these are the four basic requirements of vehicles used in the soft gelatin capsules. And these vehicles are mainly divided into two main groups. That is, first one is the water immiscible vehicle. So water immiscible vehicle, volatile or more volatile liquids, vegetable oils, mineral oils, medium chain triglycerides, and acetylated glycerins. So these are generally suitable for the soft gelatin capsules. And water miscible solvents, but it must be non-volatile in the nature, such as high molecular weight of PEG, that can be considered for manufacturing the soft gelatin capsule. So these are the two main groups in which you can divide the vehicle. Either it must be water immiscible and it may be water miscible, but which must be non-volatile in nature. All liquids used for filling must flow by the gravity. Type of filling or the basis. First type is the hydrophilic liquids like PEG 400 having high molecular weights generally, use. Generally, hydrophilic liquids we are not considering, but hydrophilic liquids which are non-volatile in the nature and those are having high molecular weights are only suitable for soft gelatin capsule. Why non-volatile and having high molecular weight? Because these are not having ability to dissolve the capsule shell. Because of their high molecular weight content and because of their viscosity, they cannot dissolve your capsule shell. Either, although it is hydrophilic in the nature. Then lipophilic liquids like soybean oils are commonly used for the drugs like steroids and vitamin D. Then micro emulsion system. Micro emulsion. First, you must know the emulsion. Emulsion means biphasic liquid dosage form which consisting of immiscible liquids. So here in this case, it consists of oil, surfactant, water system. The blend of oil and surfactant together with the active ingredient is filled into the capsule. So whatever the oil you are having, first mix it with the surfactant and then encapsulate inside the soft gelatin capsule. So first we have to prepare the micro emulsion. Micro emulsion means the globules must be having micron size, but not macro emulsion. And macro emulsions are generally not stable. Next, emulsifying oils. The mixture of pharmaceutical oil and non-ionic surfactant like polyoxyethylene sorbitol monooleate serve as self-emulsifying oil matrix. And lastly, the suspension. Suspension generally suitable for those drugs which are insoluble in the water. So those drugs which are having solubility problem, that can be converted into suspension type. So these are the 5 types of the filling which we are going to encapsulate inside the soft gelatin capsules. So your filling may be it may be consisting of hydrophilic liquid, lipophilic liquid, microemulsion system, emulsifying oil, or the suspension type of filling. So this type of filling we can encapsulate inside the soft gelatin capsule. Base adsorption. So what is meant by base adsorption? So basic, it gives the basic information to determine the minimum capsule size. Here in this image, you can see the different size of oval soft gelatin capsules. Although the size is oval in the nature, but you can see different sizes of the capsules. Oval 2, starting from oval 2, 3, 4, 5 up to oval 80. So why we are manufacturing these different sizes of soft gelatin capsule? So these sizes will depends on the mixing of your powder drug along with the vehicle. So this mixing will determines the size of your capsules. Here in this point you can see the base adsorption is expressed as the number of gram of liquid requires to produce the capsulatable mixture. Gram of liquid requires to produce capsulatable mixture when mixed with 1 gram of liquid. Means suppose you are having some gram of powdered material and slowly you are going to add the liquid phase. Slowly we have to start adding the liquid phase, and at one phase your powdered material will be having very good viscosity, it must be having very good pliability. So this is called as base adsorption. Base adsorption means it is a point when your mixture will ready to encapsulate inside the soft gelatin capsule. As such, you cannot encapsulate the powdered material or any suspension. But first, you have to mix your powder along with some liquid, that is liquid base. You have to go on adding the liquid base until it is having very good capsulatable mixture. So once you get the capsulatable mixture, then that is called as base adsorption. So on the basis of base adsorption, we can find out the capsule size. Whether the capsule size may be oval 2, oval 3, 4, 5 or oval 80. So in this way, you can decide the size of capsules. Then base adsorption of solid is influenced by the particle size and shape, its physical state, whether it is amorphous in the nature or crystalline in the nature, and density, moisture content, its polyphilic or hydrophilic nature. So before calculating the base adsorption, we have to find out all of these parameters. What is the particle size and shape? What is its physical state, whether it's amorphous or crystalline, or what is the density or moisture content of your powdered material, because it will be having direct influence of your on your base adsorption. Then determination of base adsorption. So now we come to know how you can decide the size of capsule. So size of capsule is directly dependent on the base adsorption. And how to determine the base adsorption? First, you have to take 40 gram of solid phase in a beaker. Whatever the powdered drug you are having, take 40 gram of powdered material in a beaker, 100 ml beaker, and on other hand you can take liquid base 100 gram. So in this way you are having two beakers. In one beaker you are having your solid drug, and in another beaker you are having liquid base. Suppose you may consider arachis oil or any aromatic oil or any volatile oil, whatever the vehicle we are using to prepare the liquidable mixture. So in this way you are having two beakers, one containing solid drug and other containing liquid base. And slowly we have to start adding liquid base to the solid drug. Slowly you have to start adding. Add small increment of base to the solids using spatula until the solid is completely weighted and uniformly coated with the base. So in this way, in small increment, you have to go on adding the liquid base to the solid base until you get the desired consistency. So this should produce a soft ointment like consistency. So until you get soft ointment like consistency, you have to go on adding the liquid base to solid base. And you may continue this procedure until you get the flow, that is flow steadily from the spatula blade when it held at 45 angle above the mixture. So as we are going to mixing this powder with the liquid base, so you have to keep on mixing until the mixture flows at 45 angle.
स्टूडेंट फोन करेगा उसको जिला परिषद में फॉर्म कर देगा मैक्सिमम मार्क्स और सीजीपीए का समय में.
So finally you can calculate the base adsorption by using this formula, that is weight of base divided by weight of solids. So by using this formula you can calculate the base adsorption. So how to calculate the base adsorption? Weight of base. And what is the weight of base? Here in this diagram you can see initially you have taken 40 gram of base, and in this 40 gram of 40 gram of solid drug, and in this 40 gram of solid drug in smaller increment you are adding the liquid base until you get the soft ointment like consistency which can flow steadily from the spatula when you held at 45 angle. So it may take near about 80 gram of liquid phase or 90 gram, or it may be up to 100. So how much amount of liquids requires to get the soft ointment like consistency, that volume you have to calculate. Suppose finally you achieve this desired consistency after 60 ml, so you can calculate the base adsorption like 40 gram of base divided by 60 ml of liquid, or you can calculate the weight of that liquid. So 60 ml of base or 60 gram of base divided by 40 gram of powder. So in this way you can calculate the base adsorption, and if the value of base adsorption is less, the capsule size will also less, and if the base adsorption is very high, then the size of capsule will also goes on increasing. Suppose here in this example we have considered 60 gram of base and 40 gram of solid. Here in this first beaker you can see 40 gram of solid. So 60 divided by 40, it may be around 1.23. So the base adsorption is very small. So that's why the size of the capsule will also very less. And if the base adsorption is very high, suppose you may consider up to 40 or 50, then size of the capsule will also goes on increasing. So in this way, on the basis of base adsorption, you can calculate the size of capsule. Here in this image you can see The base adsorption of the first capsule was around near about, you can say up to 1.7 or 1.8. That's why we are preparing the capsule whole capsule of 2. And as the ratio goes on increasing with base adsorption value, as the base adsorption value goes on increasing, the size of capsule is also goes on increasing. So the base adsorption value will decide the size of capsule. Next, minim per gram factor, M per G. The base adsorption used to determine the minim per gram. So volume in minims, that is occupied by 1 gram of solid plus weight of liquid base, requires to make capsulatable mixture. So we have seen that initially in small increments we are going to add the liquid base to the solid material, and a specified volume, finally whatever the specified volume you are getting, which is having the desired consistency. So on the basis of that volume, you can calculate the minim per gram factor. So minim per gram factor is calculated by dividing the weight of base plus gram of solids, that is Ba plus S, by the weight of mixture per cubic centimeter, or directly you can multiply by 16.23 minims. So by using this formula, you can calculate the minim per gram factor. That is Ba plus S, that is weight of base plus gram of solid base into V by W, that is your V capital V, that is weight of mixture, that is capital W, or you can consider 16.23 as V. So from this you can calculate the mean per gram factor. Lower the base adsorption, smaller will be the capsule size. So in previous image we have seen the different size of capsule. So lower the base adsorption, smaller will be the capsule size. The next, manufacturing of soft gelatin capsule. It is manufactured by 3 methods. First one, plate; second, rotary dry process; and third one, reciprocating and aquagel capsule filling machine. Let us first discuss what is meant by plate process. So place the gelatin sheet over a die plate. Here in this image you can see lowest image, you can see this is called as die plate, and the middle layer, that is called as gelatin sheet, and the topmost is second layer of the gelatin sheet. So you have to place the gelatin sheet over the die plate, and once the gelatin sheet placed over the die plate, you have to apply the vacuum. Once you apply the vacuum, the die plate get filled with the gelatin shell. So once there is formation of gelatin shell, you can incorporate your liquid material, liquid or semi-solid, whatever it is. You can encapsulate your solid, liquid or semi-solid mixture, and once the filling is done, then finally you can apply second sheet of gelatin paper, and directly you can seal it by applying the heat. So in this way, you can prepare soft gelatin capsule by means of plate process. So what is the process? First you have to take a die plate, and then you have to apply first gelatin plate. Once you place the gelatin sheet, you have to apply the vacuum. Once you apply the vacuum, there is formation of this type of pockets, and you can fill your medicament inside of this pocket. Once the filling is done, you can apply second layer of gelatin sheet and then press it. After pressing, you can separate the final soft gelatin capsules. Second one is the rotary dry process. So I will describe this process by using this animation. Here in this animation you can see there are two rotary dies, and each of these rotary dies are having this type of pockets to prepare the hard gelatin capsule. And in this light bluish color is there. So this one is the first gelatin sheet, and this is the second gelatin sheet. So both of these gelatin sheet get filled at the center, and after filling, both of these gelatin sheet get sealed by the rotary dies. Here From this image you will get the idea of manufacturing. So there are two hoppers. First one is the hopper containing the medicament and second hopper containing the gelatin mixture. So first the gelatin mixture will transfer over a drum. So once you transfer over the drum is having very chilled environment. So because of cool environment, this gelatin solution directly get converted into this type of gelatin sheet. So in this way, gelatin sheet will coming in between the rotary dies from both of this side. One gelatin sheet is coming from left hand side, other gelatin sheet is coming from right hand side. So in this way, the gelatin sheet get filled by the medicament at the center, and after filling, directly there is sealing of soft gelatin capsule. Here in this video, you can see there are two rotary drums are there. This is the gelatin sheet which is coming from the drum which is having very chilled environment. So the gelatin solution get converted into this type of gelatin sheet. So this type of gelatin sheet is coming from both left and right hand side, and at the center there is filling of gelatin sheet by means of medicament, and after filling there is directly a sealing process. Sealing may be by either by means of heating. So in this way there is formation of soft gelatin shells. So this is called as rotary process of preparing the soft gelatin capsules. Then next one is the Aquagel capsule filling machine. It is having three components or three parts, that is measuring roll, die roll and the sealing roll. There the top one is your measuring roll. Why it is called as measuring roll? Because it is going to transfer the measured doses. Suppose each of your soft gelatin capsule required to fill by 1 ml of medicament. So this 1 ml of medicament are transferred by means of this measuring roll. So measuring roll will transfer the measured doses into your soft gelatin capsule. Then apart from measuring roll, it is having another two rolls, that is die roll and sealing roll. So once the medicament fill inside the die roll, then second sheet of gelatin will try to seal this soft gelatin capsules. So once the filling is done, the second gelatin shell will help in encapsulating the medicaments. So measuring roll and die roll rotates and the measured doses are transferred, and then continuing rotation, because of continuing rotation of the filled die coverages with the rotating sealing roll. That the second sheet is applied to form the other half of capsules. And pressure develops between the die roll and sealing roll helps to seal and cut the soft gelatin capsules. Then let us see the difference between the soft and hard gelatin capsules.
तो